All right. So I'm going to be talking about cube assessments. My name is Mike Kaufman, and I'm a domain architect and software developer at CCI. It's on. And it's kind of a pastime to solve Rubik's Cube while I'm compiling code. Some of the things that we're going to hopefully get through today is we're going to learn a little bit about the Rubik's Cube. We're going to see how it kind of relates to assessment. We're going to put a spatial spin on it and see how it also relates to GIS. And remember, this is a programmer's perspective. So a little bit of facts. The world record of solving the Rubik's Cube is 5.6 seconds. In 1974, it was originally named the Magic Cube. And cubaholics can suffer from Rubik's wrist and Rubik's thumb programming or solving on a speed cube. So pop culture gives us, or we ask this ultimate question, and we're expecting an ultimate answer. Pop culture gives us the answer of 42. And the minimum number of turns to solve the Rubik's Cube is 20. So you could argue that 42 equals 20. So we're all after the same thing. We want to solve this thing as quickly and accurately as possible. We need to follow the rules. We can't take the cube apart or peel off the stickers to solve it. And we need to justify the results when we're done. So there is a little bit of a spatial aspect to this thing. You know, we're able to turn it around and look and analyze it. The thing is always getting mixed up. Sales are happening, people are coming to my desk and mixing it up, and so we need to solve this problem over and over again year by year. So we need to create a system, but we need to know how it works first. So the core of the cube could actually maybe be associated to the assessment fundamentals. The corners and the edges, maybe we can think of those as the parcels, the neighborhoods, and the areas that we're going to solve. And then the turns, how we're going to turn it, is the legislation and the calc rules. So there's multiple methods to solving the Rubik's Cube. You can take a layered approach, there's a corners first approach, and there's the sprinter method. There's also a hybrid method where you can do whatever you want. And then assessment, you can relate those to the market cost and maybe the income. So what we want to do is we want to build this first system to help us solve this. And it might be a little bit slow at first. This robot can solve the cube in about 2 minutes. He's not very attractive, and he can only solve a 3x3, so he has limited functionality. So we kind of talk about, well, how do we design a really well system when we're going to rebuild it? And we want to make sure that some functions are reusable. It's configurable, and which would lead into agility, and extensible. We want to be able to add functionality in that. So we build our new system in this cube stormer, made out of Legos, cell phones, internet connections, and controlling devices. Can solve the cube in 5 seconds. So now we're getting someplace. We're getting some nice performance out of our system. But our counties are growing. The parcel counts are getting bigger. So we have to take what we built, reuse the functionality, build a new system, and possibly create adapters so that we can solve 3x3, 4x4, 5x5, 7x7, what have you. But then we discover that we have new requirements, new customers, and how do we solve all of these other problems? Well, and this could possibly just be a conversion problem where we need to figure out how to get these other cubes into a square so that we can solve it. But then we have changing requirements also. The rules, the regulations, restrictions, methods, they can all change. Legislation can say that you can only turn the cube left all the time to solve it. Or we may need to actually solve it into a checkerboard pattern. But then we're talking about, well, how about GIS? How does that relate? CAMA to GIS is like the Rubik's Cube to its colors. It can still be solved without GIS, but it makes it incredibly hard. It makes it harder, and it's not as easy to validate when you're done. So here's some critical thinking. Which one of these is spatial? The one on the right, it has attributes on it, but we're not quite sure if they're spatial attributes. The one on the left, we can see that there's some sizes, and so we could possibly, knowing what the faces look like, could solve the cube. So validation of our calculations, GIS provides some visual validation. And here, both of these cases are completely possible in the Rubik's Cube. The anomaly in the data, or maybe we're missing some requirements and didn't solve it quite right. So we come to this thing called cube parity. So if we're missing data, like 3x3 here, you can actually get into this cube parity with a 3x3. Or maybe, and that could possibly relate to missing data or modeling errors. The 4x4, this is totally possible as well. So, but in the end, once we figure out what we've done wrong or what we need to redo, we've gotten the answer. to the ultimate question, the answer to the ultimate question, which is a solved Rubik's Cube or your solved appraisal. So I want to thank you very much for your time, and hopefully you learned a little bit about how the Rubik's Cube relates to assessments.